record this, it won't take long. So today we have a pretty cool idea. You guys were wondering at some point why it was that the number on the periodic table that showed the mass was not the same mass as isotopes. It wasn't a whole number. There was a confusion. People were like, oh, we'll just pull the mass off the periodic table when I'm talking about an isotope. You can't do that because the number on the periodic table is an average. If I was to hand you a block of silver, or you go out into the mountains and you dig up a block of pure silver, you're like, yes, I'm rich. Cool. Okay, so let's say you had a few billion atoms of silver. A couple of those billion would be silver 105. Silver's average mass is 107.8. So a couple billion would be silver 105. A couple billion would be silver 106. A couple billion would be silver 107. A couple billion would be silver 108. The mass that shows up on the periodic table is actually a weighted average of all the silver isotopes that exist. It's pretty slick. Now, what is a weighted average? Well, it's different than a normal average where you just add up all the number and then divide by how many you had. Like if you want to know your average score, you'd add up all your scores and divide by how many you had. Well, a weighted average is very, very different. Although you've done weighted averages before. Where do you do, or when do you do weighted averages? When do you do them? Yeah.
Isn't it in like school, if you have an honors class, you can say it's a weighted class, and you got 0.025 added on to your unweighted.
Yeah, but the counselors do that with a computer. But when do you do it?
Calculating your grade.
Exactly. You're like, at the semester, you're like, what do I have to get on my semester exam so I can get a B? So what you do is you take your quarter one, and your quarter two, and your semester exam. Now, your quarter one is weighted at, does anyone know what the weight quarter is? 40%. So quarter one is weighted at 40%. In the calculator, most of us realize that to put in 40%, you have to put in what? 0.40. So quarter one is 0.40, quarter two is 0.40, and your semester exam is?
0.20.
Yeah, and hopefully your percentages add up to 100%. Make sense? Okay, so what did you get in quarter one? Throw out a number.
89.
89. You got 89 for quarter one. What did you get for quarter two?
92.
91? 91? And what did you get in the semester exam?
37.
37. 50%. Okay, let me know that. All right. So, yeah. I got a 37%. I didn't do so good. So, let's see what you got. So, bang on the calculator and find out what you get for the semester exam. Or for the semester grade. For the semester grade. Now realize, just like any average, a weighted average will fall between your lowest and your highest number. You should never get an average that is higher than your highest number or lower than your lowest number. It should fall in that range. 82 even? Oh wow, what a coincidence. Okay. So you got an 82.0. Okay. So you just take what we're going to call the abundance multiplied by the mass, the percentage by the number, or add that to the percentage by the number, add that to percentage by the number, and that's what the average atomic mass is. What chemists have been doing, and they're constantly redoing it, is they're taking the abundance of an isotope, multiplying it by the mass of the isotope, adding it to the next abundance of the isotope, next isotope, add to the mass, next isotope, abundance times mass, and so on and so forth, and they keep doing that, they add them all up, and then they have the average atomic mass. That is the average mass that you're going to find if you dig up a chunk of silver in a mountain. Now, also new to this unit, I mentioned it before, but we're going to spend a lot of time on it, is the idea of the mole. The mole is a number like a dozen. So if you're going to go buy donuts for the football team, you're like, okay, we're going to need 8 donuts. There's 12 of them. We're going to need 8 donuts. How many donuts are you going to get? Okay, let's make it really easy. Let's say you're going to get 4 dozen. So you need 4 dozen donuts. How many donuts will you buy? 48, right? So a dozen is a specific number. If you're gonna do a breakfast, and you're like, okay, we're gonna need 6 dozen eggs. How many eggs are you gonna get? 72 eggs. Okay. A dozen is a specific number. Just like a mole is a specific number, the mole, we talked about it before, we're going to spend a lot of time on it, is 6 times 10 to the 23rd things. It turns out to be a very important number, and it's a ratio of things we can weigh out, grams, and things we cannot weigh out, atoms. Okay. Let's just jump right in. Any questions so far? All right, cool. So again, on the periodic table, you're going to find a symbol. You know this. You're going to find an atomic number, and once again, the atomic number is the number of protons. This will not go away. This will be with us for the next 7 months. Sometimes you find the symbol in the name, but what you don't find on the periodic table is atomic mass. Okay? You don't find atomic mass because atomic mass is the number of protons plus the number of neutrons for a single isotope. What you will find is the average atomic mass that we're going to call the molar mass. This is the mass of a mole of things, which is 6 times 10 to the 23rd, which is a lot. It's like a million, billion, billion. So you have a whole bunch. When you find a mole of something, you're finding a mixture of all the isotopes that you can find. And it's generally considered to be what the average atomic mass is generally considered to be the average abundance all over the globe. Understand that some isotopes are more prevalent in different places. Like we set a lot of nukes off in New Mexico and Nevada, so some of the isotopes are way off in New Mexico and Arizona and Nevada and Utah and surrounding areas where there was fallout of those heavy particles. But for the most part, we take an average globally. This is what you'd expect it to be globally. Okay, so again, an isotope of chlorine could have a mass of 36, but chlorine's mass on the periodic table is 35.5. And the unit we use for mass is gram per mole. We call it molar mass, and the unit we use is gram per mole. And we'll talk about more about this on Monday. Okay, how are we doing so far? You ready to do some more molar mass practice?
Yes.
Some of you are madly scribbling, trying to write everything down, but tough patooties, we're moving on. Okay, so natural abundance, isotopes. Again, we talked about this. Don't write all this stuff down because we just talked about it. Elements have a mix of lots of isotopes. The same element has the same number of protons, different number of neutrons, and then the molar mass is simply calculated by, you take the first isotope, you multiply its abundance by its whole number weight. And the AMU stands for atomic mass unit. If you're using whole numbers, we use atomic mass unit. For now, in this class. Then you take the second isotope, do the same thing, multiply the second isotope's relative abundance by its mass. And then you just keep doing that until you run out of isotopes. Then you either add the pieces together, or write the pieces down and add those together. Some people want to do it all in their calculator. This times this, plus this times this, times this, plus this times this, add them all up. Or some people like to do this times this, write it down. This plus this, write it down. This plus this, write it down. Either way, you should get a number that's going to fall in between the lowest and the highest number. It should be in that range. Okay. Give you a minute to scribble whatever you want to scribble, but the practice will hopefully make this concrete. We have a lab tomorrow. I just put it together. Well, I'm putting it together. I just wrote it last week. You're going to find, so the potato guns for physics, that's also tomorrow. You're going to find the molar mass of beanbagium with a bunch of beans in here. Don't eat them, they're gross, because they're dried up. And then once you do the beans, you can do the molar mass of steel ballium, or Boltium, or Marbellium. That's my favorite. Okay, give me a thumbs up if you're with me so far and don't have any questions. Okay. If you do have a question, put your thumb down, put your hand up. All right, so practice. Average atomic mass practice. Isotopes of Wagnerium are found below. Wagnerium 18 is 25% abundant. Wagnerium 19 is 60% abundant. And Wagnerium 20 is 15% abundant. If you wouldn't mind, please, find out what the average atomic mass, the molar mass, of naturally occurring Wagnerium is. Bang on your calculator. I'll come around. If you have trouble with your calculator, I will help you. Otherwise, I'll look at your answer and say, that's right, or that's not right. And don't divide by 3. Okay? You don't need to divide by 3 because the percentage does that for you. Again, you should get a number higher than the lowest number, smaller than the biggest number, somewhere between 18 and 20. So I see one almost right answer. You need to check it out. Your number is almost right. Okay. And that's good. Good. Yep. That's right there. You remember your percentages are 20. Good. Okay, so most of you I've seen have got it right. I do want to talk about some pitfalls in using percentages. So there are pitfalls in using percentages. Most people realize that, oh, by the way, the answer is 18.9?
Yes.
Somewhere around here. Here you go. Okay. 18 times 0.25 plus 19 times 0.6 plus 20 times 0.15. I realize most of you are doing this in your calculator. On the worksheet you're doing today, please show your work. Okay. I realize most of you are just going to bang it into your calculator, but I need to know that you understand. You're not just copying someone's work. Okay. So some pitfalls with percentages. Most of you realize, and even in the heat of battle when you're doing a test, realize that 25% should be put into your calculator how? 0.25, yeah. Should be put into the calculator 0.25. How should 9% be put into your calculator? 0.09. In case no one's explained it to you, percent literally means divided by 100. It's like, how many years are in a century? 100. How many cents are in a dollar? 100. Percent literally means out of 100. So you divide by 100. Move the decimal 2 places. Yeah. Good question. So if you said 2.5%, this would put your calculator how? Yeah, 0.025. Now the trick is, this gets a lot of people in the heat of battle when you're taking a test. You hit something that's 0.1%. What is 0.1%?
0.001.
Yeah, 0.001. So 0.001 in your calculator. And if you have 0.02, this is 0.0002. Okay? So be advised, when you get percentages, make sure you move the decimal 2 places. If it's a percentage, but it's already point something, move it to 2 more places. Okay? Ready for one more, or are you ready for your practice worksheet? One more. Okay, some people need one more, so we'll do one more. Okay. Consider the element E gallium. E gallium has 4 isotopes. They are 34 AMU, we found to be 12%. 35 AMU, we found to be 25%. 36 AMU is 33%, and 37 AMU is 30%. If you wouldn't mind, please calculate the average abundance, the average atomic mass of naturally occurring E gallium.